Okay, in these notes, I've already matched up these cards. This is just a review. So this is the less than symbol, less than or equal to, because the equal sign's underneath it, greater than or equal to. So whenever you do not see a solid line, that's when you know it's a dashed line. It's kind of like an open circle back in topic 1. Less than or equal to, I see a solid line, so I know I'm going to be plotting a solid line. Greater than would be a dashed. Once again, it would be like an open circle. It's a boundary. It does not include any ordered pair that sits on that line. And then greater than or equal to would be a solid line because of that equal to part. So here it says graph the following system. Y is less than x plus 3. So it says the line would be dashed because of the less than symbol. So let's double check. If you noticed, if you graph this, it actually plots a dashed line for you. So that is like an open circle. Any ordered pair on that line would get you a false statement because it's just a boundary. It's not included. Now, if I picked the point 0, 0, and I plug that in, 0 is less than 0 plus 3, or 0 is less than 3, that's a true statement. So if I did that for every single ordered pair here, that's why it's a solution. Now the second inequality, it's y is greater than or equal to x minus 4. Notice that this is a solid line. So I'm going to go back to question number 4. And the line would be a solid line because the greater than or equal to symbol. All right, so slide number 6 is the same idea. So you're going to graph that on slide number 7. So it says y is greater than 3x minus 6. Notice that there's no equal sign, so that's why it's a dashed line. Okay, so if we picked an ordered pair, let's say 2, 0, it would get you a false statement. Now let's pick x is greater than or equal to negative 1. X is greater than or equal to negative 1. And notice how this graph, this linear inequality, now has a solid line because of that equal sign. Now when we get further into the lesson, I'm going to ask you what is a solution to this. A solution to the system is when you are inside the double shaded. So if I pick 0, 0, I'm going to get a true statement and a true statement. But for right now, just asking, this would be a dash line because of the greater than symbol. And then this would be a solid line. Not because of the greater symbol, but because of the equal. That equal makes it a solid line. All right, so question number 3. This is where we actually talk about the possible solution. Remember, your possible solution should be very different than somebody else's. It just needs to be in the double shaded. So we have y is greater than negative x plus 4. Now graph the second inequality right after it. So then y is less than or equal to x minus 2, I believe. Okay. So you want to pick any ordered pair that is in this region. in the double shaded region. I recommend staying away from the line, but since this line is solid, any ordered pair that's located here, because it's touching the double shaded, would be a solution. And then any point here on the dotted line or dashed line would not be, because remember, it's like an open dot. So I recommend staying clear of the boundary lines, maybe just saying 9, 1. And you're looking for 2 trues. So this needs to be a 2 true area. Now what 2 trues mean is you plug in the ordered pair 9, 1, and you plug in the y, plug in the x, and y is greater than -5, so that's true. Now move on to the second one. You're going to use the same ordered pair. y1 is y is less than or equal to 9 minus 2, and 1 is equal to or less than 7. So that's where you got your 2 true area. Now you could zoom out and you could choose, let's say 100, 1 or 300, 5. That would be acceptable because that's in the both true area. So what I mean by that, I could choose 150, 50, and that would be true. And it would be true for both. So remember, you want double true. Question number 10, or slide number 10, question number 4, is truthfully just like a multiple choice. So we have y is less than -2x minus 3. Now be careful, this is a dashed line. So when you're doing your multiple choice, make sure that your red line, or the one that is less than, has your dashed. And then we have y is greater than or equal to 1/3 x plus 2. And then just make sure that your 1/3 x plus 2 has your solid line. So for me, this would be my choice. Yours is going to be maybe in a different location, but the double shaded is in the top left, solid line, and then a dotted line. So double check, make sure that you click on the correct one. All right, slide 12, 13, and 14 are identical. All the difference is the graph. You want to find an ordered pair that's a solution. So if you put your ordered pair here, that would not be correct. That's just a solution to the red inequality. This would be a no solution to any of them. You would get 2 falses. You would get a true for the blue, but we want true for the both. So if you put it anywhere in this purple region, you will get the correct answer. 13, same thing. Find the double shaded area. Put your ordered pair. 14, find the double shaded. It would be correct. All right, question number 15. It says Joseph moved the point to 2, 7. Is this a solution to the system? The correct answer is yes. Notice that this is the double shaded area. And he put his ordered pair on the solid segment that is touching the double shaded. Since he did that, we know that it's correct. Now, if he would have put it on this dashed line, then that would not be a solution because that's just a boundary. 2, 7 is on the solid line touching the double shaded. So we know that it would be a solution. Now, even if he moved it down here to 0, 1, that would not be because it's not touching the double shaded. So it has to touch the double shaded and it has to be on the solid line. All right, last question, slide 16. It says, given the following system of inequalities, are your ordered pairs a solution? So we're going to check. So y is greater than x minus 4, and y is less than negative x plus 2. So we have a very large region. We have a double shaded area. That's where we're looking. Now I recommend negative 1 comma negative 1, actually just putting that ordered pair here and seeing if it is in the double shaded. Yes, it is. And then 0 comma 2. 0 comma 2 would not be because it's on the boundary line. So yes, because it's in the double shaded, and then no, because it's on a dotted line touching the double shaded. So something along those lines, and you can show your work by doing two trues. And this one would get you 2 false statements. But honestly, I don't need to see that work. If you just put it in the graph and know that the double shaded is your correct answer, you are good to go.